Good morning, everyone. I'm Lisbeth. I'm here with my colleague Linda, and today we will talk about bilirubin assay. So, how to execute the bilirubin total and the bilirubin direct. This session will be given in different pieces. I will start with a brief introduction on Cyprus, on who we are, and then we'll move on to the context and the required material to do the bilirubin. In addition, we'll show you more about the principle and the key takeaways. And then as well, Linda will give you more information about the procedure and we will do a live demonstration. In this live demonstration, we'll show you how to do the bilirubin for one single sample, but we also show you how to do it with 5 samples at the same time. And of course, there is a summary chapter at the end in which actually questions can be raised, and I will do my best to answer them to you. So let's start with a brief introduction on who we are. So we are Cyprus Diagnostics. We are based in Belgium, and we have been founded 30 years ago. We are also ISO certified, and we are a manufacturer of in vitro diagnostics devices. At the moment, last year, we provided 75 million tests on the market, and we have a goal by 2030 to reach 100 million tests a year. We want every laboratory to have all of the documentation, but also have all of the materials ready to perform good and correct analysis. So in that view, we have a platform-based approach, and that means that we offer analyzers like the Cyan Vision and like the Cyan Elite on biochemistry. Next to that, we also offer reagents, calibrators, and controls to make sure that after the measurement of the patient sample, you can check whether this is a valid result. And then, of course, there are the consumables and the training and the support team to support you in case of any questions or in case you need more documentation. We have a very strong commitment in terms of quality and in terms of your satisfaction. And therefore, actually 45% of our employees are directly dedicated to the quality of our products. This can be in several departments. They are in quality control, or they are in regulatory affairs, which also help you to build the documentation, but also to make sure that you can register at your Ministry of Health. And then, of course, we have the training and the support team in which Linda is part of to support you and to give more trainings and information on our products. Also, internally, more than 100 training courses are given. This to retrain and to always update the skills of our teams so that every lot that is released from our factory and every instrument that is released from our factory, that this is in good quality and it can be compared to what has been released previously. Before we really start on the bilirubin, I just want to stipulate again that it is vital for the patient that our results are clear, correct, and consistent. Suppose that the patient goes to the hospital or the blood is taken. There are 2 ways to do the analysis. There is a wrong way to do so, and that means that the laboratory is working without doing any controls or without doing any good laboratory practices or not knowing how to do the procedure. This will always lead to false results, and this will really harm the patient. This is not the goal of the in vitro diagnostics. However, when you do it the right way with the right materials, using the Cyprus platform, but also using the good laboratory practices, the right methodology, and checking it with the quality controls, this will always lead to clear, correct, and consistent results. And this way we can help the patient to get better and to make sure that the right diagnosis and the right treatments can be taken. All right, so that brings me to the second point of this presentation, which is the context of the bilirubin and the required material. And therefore, I'm glad to pass my word to Linda.
So to give you a little bit of context, what is bilirubin and what is it used for? When in the body, old blood cells break down, this produces bilirubin. This is processed in the liver and then eliminated from the body through the intestines. If the level of the bilirubin is too high, that can give us information. It can be two causes. There can either be too much breakdown of red blood cells, which could be a sign of hemolytic anemia, but there could also be a bad elimination, like for example in liver diseases, or there can be an obstruction like gallstones. Now, which one of the two is the cause? That's where the BILD and the BILT come in. Because in the body, there are two forms of bilirubin. There is the conjugated one. This one can easily be measured in a direct way in the blood. That's why we call it bilirubin direct. This is the BILD test. There is also a free form. This one cannot be detected directly in the blood because it's insoluble in water. We first need to add DMSO to the reagent, but then we measure both forms together. So we will measure the conjugated and the free in the blood, and this test we call bilirubin total. To know the concentration then of the free bilirubin, you simply make the difference between the BILT and the BILD. And so because this form is not measured directly in the blood, but is calculated, that's why it's also sometimes called indirect bilirubin. Now, what's the clinical meaning of this? The free bilirubin is the one which is produced immediately after the red blood cells break down, and then after being processed in the liver, it becomes conjugated. So either which form of the two is elevated in the blood will give us the information if the problem is before or after the liver. Our bilirubin tests, our assays, they are intended for a quantitative measurement in human serum or plasma samples. You should never base a diagnosis based just on one single test, but you should integrate clinical data and other laboratory data too. What's the material that you need to perform a bilirubin test? Well, first, you need a bilirubin direct and or total kit. These are available either combined or separate. You also need a spectrophotometer or a colorimeter, such as a Science Smart, Vision, or Elite, plus the matching cuvettes. And last but not least, very important for this assay, you need a digital lab timer. That brings us to the principle and the key takeaways. We will start with the key takeaways, and then we'll explain why these are so important, and that will bring us automatically to the principle. So what makes bilirubin different from other tests? First, bilirubin is light sensitive. You need to protect your sample tubes. Bilirubin is stable for 4 days between 2 and 8 degrees, but only when it's protected from light. So as long as you keep your samples in the fridge, they're protected, but as soon as you take them out to let them come at room temperature before performing your test, it's better to take extra precautions and protect them with, like example, aluminium foil, or put them in a closet or in a small cardboard box on your desk. Second key takeaway is that the timing is really essential. So incubation needs to be exactly 5 minutes at room temperature. The principle of a colorimetric assay is quite simple. You use a reagent, you add it, and this reagent will react with, in this case, the bilirubin to form a red color. And the intensity of this color is proportional to the concentration of bilirubin. As you can see in the picture, the higher the concentration is, the darker the red color is. For this color to form, you need a certain reaction time. So this reaction has an incubation step. Bilirubin is what we call an endpoint assay. That is because it's a one-time point measurement. Normally, for an endpoint assay, you first perform the incubation, after which the reaction comes in a stable zone. That's where the absorbance stays the same, and this is where you will do the measurement. Usually, you have quite some time to do this. Typical examples are 30 minutes or even 60 minutes, that you can perform the measurement of the absorbance because it doesn't change anymore. But for bilirubin, there is no stable zone. As you can see on the red graph here, the absorbance just keeps increasing. So this is the reason why we have to measure after exactly 5 minutes, because that's the only way to assure that every test you will perform for every patient, but also the calibrator and the control, that every test will be performed in exactly the same way.
This brings us to the third key takeaway. A sample blank is required for bilirubin. That means that you will need 2 tubes per patient, one to have the noise or the background coloration of the sample, and the second one to see the real reaction. Let me explain you why and how it is made. So if I would ask you to spot the difference between the first tube that you see and the second tube that you see here, you would say that you don't see a difference. And of course, visually, there is no difference. But there is a big difference between the two of them. On the first tube, actually, what you see is a bilirubin color reaction. That means that the bilirubin has been reacting with the reagent and formed a red color, as Linda said. In the second tubing, there is an interference of the sample. So that is just the color of the sample itself with a dilution by the reagent. So there is a big difference between the two of them. If we are not able to see it, the instrument is not able to see it either. So therefore, actually, we will need 2 tubes to make a difference between the real reaction and the interference of the sample coloration. Secondly, we have different kind of reactions in biochemistry. When you have a strong reaction, that means that the coloration of the reaction with the parameter is high, and that there is a big difference between the background and the reaction itself, as you can see on the picture. Unfortunately for bilirubin, this is a weak reaction. So that means that the coloration itself coming from the real reaction of bilirubin with the reagent is not very intense. And that means that there is only a slight difference between the background and the reaction itself. So it's difficult to see the difference, and we will need an instrument to really measure the difference. We are not able, as a manufacturer, to make this weak reaction towards a strong reaction because it's just the nature of a bilirubin testing. And then, of course, we have the point that there could be a background variation. Here you see, again, 3 tubes. The first one is slightly dark red. The second one is clearly lighter. And the third one is the most dark. However, based on this, we cannot say in which tube we have the highest concentration of bilirubin, because there could be a sample background variation. It could even be that the sample 2 has a higher bilirubin concentration than the sample 3. So we need to perform a sample blank, and this for every sample, to make sure that if the coloration is red of the sample, or yellow, or green, or orange, whatever the background color is, that actually we are going to subtract this specific coloration per sample. Okay, so the sample blank principle is as follows. You see 2 tubes. The first one is the background tube. The second one is the reaction tube. That means that you see a coloration that comes from the background plus the real bilirubin coloration of the reaction. If you make the difference between the two of these, then actually you will see the real coloration of the reaction, and that is equal to the bilirubin concentration. Okay, if we look at a terminology that Linda will also use in the coming demonstration, you will see that the first tube, where it's only one reagent and the sample, we will call it the sample blank. In the second tube, where you have the real reaction of bilirubin, we will call it the sample. And actually, we are going to make the difference between the two of them.
That brings us to the procedure with live demonstration. First, let me remind you of the different steps that you need to take before you can start measuring patient samples. You always need to start with the auto zero. Then you perform a reagent blank. Then when it's the first time that you perform the bilirubin test, you need to do a calibration. And to make sure that your calibration has been correct, you need to double check it by quality control. And only when your controls are good, then you are ready to start measuring patient samples. So I will skip the AutoZero today because this is the same for every test, and we have treated this in previous seminars. So we will start from the reagent blank, because from here it's different for the bilirubin test. Small remark, this is not the case for the Science Smart. For the Science Smart, it's still the step for the reagent blank is still the same as always. So you just simply measure one reagent, you perform one blank measurement actually. And in this case, it's the reagent T. But for the Science Vision, it's different because you perform two measurements. You will perform one for the reagent T and a second one where you will measure both of the reagents. This has been an improvement. It will help you get more precise results. To help you remind the different volumes to use and the different steps, we refer to the application sheets. As you can see in the following, this is what I will show you in a minute. For the reagent blank, we're going to perform the two measurements. So in the first step, you add the reagent T, 750 microliters. This goes in both of the tubes. Then we will add the reagent N, but this only in the second tube. And then we will mix. And then last, we will perform the measurements. I will show you right now. So I always start by preparing two tubes. And I will use the two rows, the first row for the blank and the last one for the specific reaction. We will use the same terminology as Lisbeth explained. So the first tube is for the reagent blank and the last one we call it the reagent. So we start by adding the reagent T. That's this one. I've already aliquoted it. This goes in both of the tubes. Then the reagent N, which I've aliquoted here. This goes only in the second tube, which is the reagent. Then mix. And we can perform our measurements. I hope you can see it well on the little screen. The device indicates what you need to measure first. So it asks for the reagent blank. So this is the tube on the first row. We offer this first. Measure it. You will see that the device starts measuring the first OD. And at a certain point, it will stop the measurement and it will ask now for the reagent tube, which is the second tube on the last row. We offer this one. And the device continues measuring the second OD. So that's the step of the reagent blank. When this is finished, you are ready to perform your calibration. For this, we can offer our biochemistry calibrator, reference HBC03. So I just want to remind you once again that sample blank is required for the bilirubin test. This means you need 2 tubes per patient. And this is not only the case for your samples, but it's exactly the same also for the calibrator and the controls. So what I will show you now is, again, we will prepare 2 tubes. So as Lisbeth explained, in the first tube, we want to measure the background, so the interference of the sample. How do we do that? Well, in this case, we have a calibrator, but we add only one reagent. That's to measure background. So this will be the tube, we will call it the calibrator blank. Then in the second tube, we want to measure the specific reaction plus the background. For this, we will add both of the reagents. This tube we will call the calibrator tube. We will always work in a certain order because this is easy to remember and it will give us sufficient time to do all the different steps and to have sufficient time for the 5 minutes incubation. We will start with the calibrator first. We will add a 100 microliter to both of the tubes. Then we will add the reagent N. This only needs to be added to the second tube, which is the calibrator tube. And then we will mix. And then as soon as we add the last reagent on the second reagent, that's when we need to start our timer because we need to start incubating for exactly 5 minutes. And then we will mix. I will show you right now. So once again, I prepare 2 tubes. So the first will be the calibrator blank, and in the last row we use the calibrator tube. I start with calibrator. I pipe it 100 microliter in the calibrator blank tube and then in the calibrator tube. I add the reagent N only in the second tube. Prepare my timer. So when I pipe it the reagent N, I need to do that exactly when I start my timer. And I vortex. So this is the calibrator blank tube. Then I will also already prepare the second tube, which is the calibrator. And I will do that after exactly 30 seconds, because that's easy to remember. So I will add it when the timer arrives at exactly 30 seconds.
So as Linda showed, we need to pipe it at a certain time and we need to exactly respect the 5 minutes at room temperature for the incubation. Okay, let me show you what happens. So what she did is in the first tube, in the calibrator blank, she added 750 microliters of reagent T at time 0. Actually, this is going to be incubated for 5 minutes. So we will measure it when the timer is exactly at 5 minutes. Then secondly, at 30 seconds, she prepared the calibrator. So that also means that after 5 minutes of incubation, so at 5 minutes 30, we will do the measurement. So actually, this is what will happen. So it's very important to keep strict to this timing given. In the meantime, while we wait that the timer is at 5 minutes, what I just want to indicate is that the color intensity will be proportional to the bilirubin concentration. And here we are doing a calibration. So that means that the bilirubin concentration is equal to the difference of the 2 tubes times a factor. But how are we going to determine that factor? So to determine that factor, actually, we have 2 unknowns. First, we have the concentration of the calibrator, and secondly, we have the absorbance of the calibrator and the absorbance of the calibrator blank. So what we see in the concentration of the calibrator, which is indicated here in the formula in green, is that we don't really have a problem because in these flasks of the human calibrator, We also add a table with the right value of the bilirubin total and for the bilirubin direct. So you have this lot specific value for these elements. Then secondly, we need to determine the absorbance of the calibrator and the absorbance of the calibrator blank. Well, that is what we just did. We have pipetted it in the right way with the correct timing, and we will measure this after 5 minutes. If then the measurement is done, we are able to calibrate the difference between the two of them, and then just by dividing the concentration of the calibrator with this difference, we will obtain a factor. I am going back to Linda to see, okay, we are at 3 minutes 30, so we still need a bit of time to before we can go on with the measuring. A small word on the calibrator. The calibrator and the calibration is really just to determine a factor. That's the only thing. It will give you a number. Is this number correct? That we cannot say by only doing the calibration. To verify this number, we will need a quality control, which also will be shown in this presentation. And to know that, well, this calibration, this factor has been done correctly. Secondly, for bilirubin direct and for bilirubin total, there is a standard factor in the instrument, in the programming of the instrument. So if you would like to use that, there is no problem. However, you need to check that for that specific reagent, it is okay, that factor is valid. And how do you do that? By doing the quality control and by knowing that the quality control is in range. If that is not in range, then you will need to do your own calibration with a calibrator. I'll pass the word to Linda because it's time to measure.
Yeah, it's almost time. So you can see that also here, the device will indicate the first tube that you need to measure. So it's the calibrator blank, which is in the first row. So we will offer this and we will press aspire at exactly 5 minutes. The device will start measuring the calibrator blank, which is the first OD. And then you will see that the device will stop and wait for the second tube, which is the calibrator. So the calibrator tube is in the last row. We can offer this, but we need to be patient because we will measure this when the timer is at 5:30, exactly like this. So that's finished for the first measurement of the calibrator. You will see now that the device asks to do 2 more repetitions. We will now switch back to the slides. The 2 repetitions are there because the bilirubin test is more critical than other tests. You need to work in a more precise way. That's why the device asks to do 3 measurements, and all the 3 measurements need to be quite close one to another. We will not keep you waiting for another 2 times 5 minutes. The procedure to follow is exactly the same as I just showed you now. When you have performed this 3 times, then you will get the 3 measurements and 3 times a factor calculated. And when the calibration is fine, it means that all the 3 measurements are close to each other. Then the device will calculate an average factor, which you will get from the following slide, which here is 10.10. This is the factor which will be used for your patient samples for the calculation of your concentration. That brings us to the step of the quality control. For this to help you, we have developed a biochemistry normal control and a biochemistry pathological control. So to remind you, as already explained also by my colleague Lisbeth, what's it for, the quality control? So the calibration, even though when it's succeeded and the average factor has been calculated, it only means that you worked in a precise and in a consistent way. But you can never exclude that you didn't do, for example, a pipetting mistake, or you have the timing wrong of your incubation step, or your reagent has been contaminated, or even your calibrator has degraded. If you want to make absolutely sure that nothing has been wrong and that your factor that has been calculated is correct, you can only do that by performing quality controls. So then the next step is to perform the quality control. It's done in exactly the same way as I showed for the calibrator. So it's, as you can see on the side, as shown on our application sheets, you start by pipetting 100 microliter of control in 2 tubes again. You add the 25 microliter of reagent N only to the second tube, which is the control tube. Then when you add the reagent T, you start your timer and you do the second tube 30 seconds after. And then 5 minutes later, after incubation has finished, you do again the measurements with 30 seconds in between. The device will ask to do the normal control first and then go to the pathological control. And you always start with measuring the control blank and then the control tube itself. And what you want to obtain is that the values that are measured, they fall within the range of your quality controls, and there will be no flags. We have built a video on this part, so which explains the steps of the reagent blank and the calibrator and the controls. And this video will also explain how to program these values of the controls into your CyanVision. So at this point, when you have quality control, which is good, then you are ready to start measuring your patient samples. This again is the same, exactly the same procedure as I've shown for the calibrator. So instead of showing you that once again, I think it's more useful that we show you how to perform 5 samples in 10 minutes. We have built a video who explains, so this is a second video, this is specific on the samples. In the first part, it explains how to perform a measurement of 1 sample. And then in the second part, it explains how to do 5 samples in 10 minutes. And we think this one is more practical for you to show at this moment, because it will save you quite some time, not having to wait 5 minutes for each sample. I think the video is ready now at part 2 to start. Okay, so this is the video. We think it will be very useful to you. This was the video on the samples. So it has 2 parts for 1 sample and then the second part on the 5 samples. There is a second video which will explain the calibration and the control, and this will be available also very soon. Also remember, we have the application sheets. They're very useful to remember the different steps to follow. All the volumes are indicated. So there is one scheme for the blank reagent, one for the calibration and one for the control. And then there's another one which explains how to do the 5 samples in the 10 minutes. So this is, as you've just seen on the video, all the different steps. So you start with 100 microliter of sample that you put in the 2 rows of tubes, and then you add the reagent N only in the second row, and then you add the reagent T. You start with the sample blank, and then you go to the sample, always with 30 seconds in between, and always in this particular order. And then exactly 5 minutes later, in the same order, you will do the aspiration of all the samples. So also with 30 seconds in between.
So that brings us to the summary of today. So what have we learned? Bilirubin is a different test. It's an endpoint test, but very different from other endpoint tests. First of all, bilirubin is light sensitive, so protect your sample tubes. If you do not do that, actually degradation of the bilirubin will start rapidly into the sample and you will have a wrong result. Secondly, a sample blank is required. You will need 2 tubes per patient. So we'll always first measure the blank and then measure the reagent, the calibrator, the control, or the sample itself. And this per sample, not only per patient, but really per sample. And then, of course, your timing is essential. The incubation time should be exactly 5 minutes. And we have shown you for 1 single sample or a single calibration, but also for 5 samples, how you can follow the time scheme and make it happen that you respect this 5 minutes time. We also have an online learning website. On this online learning website, you can always subscribe for the next training. The upcoming sessions will be announced there as well very soon. So at the moment, they are not there yet, but they will be announced very soon. What is also different is that the previous meetings that we already had in the past regarding quality of reagents, regarding the CN vision, we also did one on preparation of samples for the different type of methodologies in biochemistry. Well, all of these videos will be posted as well on this website so that you can review these things and search for points that you do want to go get more profound into it.